Okay, we are going to review similar problems as you will find on the test. Please don't get panic. You focus, you try to understand how to do the problem, and you will find on the test a very similar problem. So if you focus, you can do it. I know that the first four problems are maybe the most difficult problems, but they are not so difficult, but maybe it seems to you that will be difficult. But after the fourth problem, all of them, they are much more easy to solve. So let's go to solve the 10 problems, 10 similar problems for the test. Welcome to this new tips for the final test. My intention is to help you to prepare yourself the best that you can. So you will find on the test 10 problems. The first problem is a problem that we have done many times. It's about marginal analysis. If you remember, marginal analysis is about finding you have the cost of producing X units, and this is a curve. And the curve says that to produce, let's say, 10 units, you will spend, let's say, $100. To produce 20 units, you will spend a total amount to produce the 20 units, maybe 210 units. Maybe you spend more money than to produce only 10 units. So 10 units, you spend $100. 20 units, you spend $210. So you spend a little bit more per every 10 units because maybe the cost that you have is higher, whatever. So the question in marginal analysis is, what is the cost to produce 1 unit? So what you do is this thing. You imagine that there is a line, a tangent line. What is the cost of producing the 11 units? This is what we are asking you. What is the marginal cost to produce the 11 units? We know how much is the cost to produce the whole 11 units. To produce 11 units, you just go here and you plug in 11 and you know the cost of producing 11 units. To produce 10 units, you go here and you plug in the 10 here and you will have the cost of producing 10 units. So here will be 5 multiplied by 11 squared plus 2 times 11 plus 5. And here the cost of producing 10 units will be 5, 10 squared plus 2 times 10 plus 5. And the cost of producing the 11 units is the difference. The cost of producing the 11th unit, because this is the cost of producing the whole package of 11 units. This is the cost of producing the whole package of 10 units. And the cost of producing the 11 units, or the 10 units, is C11 minus C of 10. This is the cost, the real cost. But in the marginal cost, we imagine that there is the tangent line here. So we ask if we follow the tangent line. Who is the tangent line? The tangent line, you know, is y equal y0. Y0 will be 10. It will be 100 plus the slope multiplied by x minus x0. X0 will be the 10. So let's go to calculate the marginal cost for this 5x squared minus 2x to produce the 10 units. So C of x is 5x squared plus 2x plus 5. So what is the slope at x equal 10? At x equal 10, the slope is finding by the derivative of c respect to the x is 10x plus 2. And the slope at x equal 10, the derivative of c respect to the x or respect to q or x is the same thing, is 10 multiplied by x10 plus 2. So the slope is 102. So this is the slope. So what is the rectilinear line? The rectilinear line is, always y of x equal y0 plus m multiplied by x minus x0. In this case, the rectilinear line that passes through the point x equal 10 is y of x is the value of x equal 10, that is c of 10 plus the slope 102 multiplied by x minus x0, x minus 10. Okay, what is the change in the value? Y of x minus c of 10. Y of 11 minus c of 10 is the change in the cost of producing 1 unit. So if I put here 11, I will have 1 here. So the cost, as a result, the marginal cost is the derivative of c respect to the x. This is the cost of producing 1 unit. And this solves the problem. You have some of the problems that we have done on marginal cost. You can see in Canvas lesson 11, I think, and you will find more problems like this one. Lesson 11A, I think, see on Canvas. Now we deal with another types of problem. It's extracting information to sketch a graph. So imagine that they tell you f prime of x is positive, means that the function is increasing. It's go up and up for x less than 10. And f prime of x is negative for x bigger than 10. How we can work with this information? Well, we write f prime of x in a rectilinear line. This is the rectilinear line. We put x equal 10, so the derivative is positive. So it's positive to the left of the x equal 10, and it's negative for the right side of x equal 10. So for x bigger than 10, it's negative. It means that the function is increasing, and after x equal 10 is decreasing. So the function is doing like this and have a maximum at x equal 10 because it's positive to the left of x equal 10, is positive, and is negative at the x of x equal 10. So at x equal 10, it has a maximum. Perfect. The second information that they are giving us is about the concavity. The concavity is negative if it's down, if it's concave down, and it's positive if it's concave up. So they give us an interval. For example, the interval that they give us is that for between 3 and minus 3, the concavity is up. For less of minus 3 or bigger than 3, the concavity is up. So we can place this information into a more graphical design like this. We put minus 3, we put 3. The concavity is negative when x is smaller than 3. Is positive between minus 3 and 3. This is the 0. And is negative when x bigger than 3. And now we have to plug in the graph. The graph needs to meet the two conditions. It has to be increasing graph for x smaller than 10, decreasing graph for x bigger than 10, and the concavity should be minus 3, should be to the left of minus 3, should be this concavity. upward. Now concavity downwards from -3 and 3. Now concavity upward from -3 to infinity. The concavity is upward. You see? Because the concavity is negative. It's negative, so it's like this. And this is the graph of the function that they can ask you. So you have to be careful, and the trick is you graph a line, and you graph the value of f prime of x, positive, 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 and for f second you put the value, so if it's negative, it's concave downward, if it's positive, it's concave upward. I hope it's clear, this problem. This problem 3, say that the value of a machine is decreasing, is depreciating. The change in the value per unit of time, the x is the time in years, is how old is the machine. The change, the slope, is 500 multiplied by x minus 5. So the question is, what is the depreciation in the first 5 years? So to do this problem, we need to apply the first fundamental theorem of calculus. So we have to do it like this. This is the change in the value of the machine per unit of time. What is the value of the machine? First question. What is the value as a function of the years, of the x? Well, I need to find a function whose derivative is this function. And this function is 500x minus 2,500. So I need to find a function whose derivative is 500x minus 250. Minus 2,500. Minus 2,500. What is this function? This function is the function 500 x squared divided by 2 minus 2,500x. And this is the general function. Well, if I add here a c, a constant c, now it's a general function, because if I make the derivative of this function, the derivative of c will be 0, and the derivative of 500x squared divided by 2 will be 500x, and the derivative of 2,500x will be 2,500, so I have found v of x. But the problem is asking me about the depreciation in 5 years. So the depreciation in 5 years is v5 minus v0. This is the change in the depreciation of the machine. v5 is 500, 5 squared divided by 2 minus 2,500 multiplied by 2 plus c. Minus v0, but v0 is just c. If you plug in 0 here, 0 will be, this will be 0, this will be 0. You see, so the c cancel. So the depreciation, the change in the value on the first 5 years is 500 divided by 2 is 250. 250 multiplied by 5 squared is multiplied by 25, minus 2,500 by 2 is 5,000. So the depreciation is, let's say, 2,500 multiplied by 25 is 6,250 minus 5,000, and this is 1,250. So the change in the value of the machine is 1,250. Can you know what is the value of the machine? No. You cannot know for the problem what is the value. You know that the change in the value is $1,250. So it depreciates this amount. If the machine costs $100,000, now after 5 years it will cost $100,000 minus 1,250. But you know the depreciation, you don't know the value of the machine after 5 years. So this is problem 3. Let's go to problem 4. Okay, let's go to do this problem. Find the equation of the tangent line y equal x cubed. Y equal x cubed, you know, is a function that does like this. It has a slope 0 at x equals 0, and it changes the concavity, something like this, is y equal x cubed. At x equals 3, there is a slope. And what is the equation of the tangent line? Well, very easy. The equation of the tangent line is y equal y0 plus m multiplied by x minus x0. So y of x equal y0. When x equals 3, y equals 3 cubed. So the point P is the point 3, 3 cubed. So 3 cubed is 27. Is 27 plus the slope. What is the slope? The slope, the derivative of y respect to the x, is 3x squared. And the slope at the point x equals 3, the slope at x equals 3 is 3 multiplied by 3 squared, or 3 cubed, of also 27. So the slope and the height in this case are the same. So the slope here and the height here are the same. Well, it was by luck. So the slope is 27 that multiply x minus 3. So this is the equation of the tangent line to the curve y equal x cubed at the point x equal 3. In the exam, you will have another function. You will have another point instead of x equal 3, maybe x equal 2. And you do exactly the same thing. If you want to clean this equation, you may do y of x equal 27x plus 27 minus 27 by 3. If you sum this, it will be y of x equal 27x minus 27 minus 27 by 3 is the same as 27 by 2, and 27 by 2 is 54. So this is the equation of the tangent line. Okay, let's go to the next problem. Okay, now problem 6 say determine the points at which the graph of the function, let's say this function, have horizontal slope. A graph of a function have horizontal slope when the derivative is 0. So what you will do is to find the derivative of y respect to the x, to put it equal 0, and to find at which x occur the facts that the slope is 0. So what is the derivative of y respect to the x? Is 16x cubed minus 4x plus 0. So this is the derivative of y respect to the x, and I want this to be 0. So I want, if I divide by 4, it will be 4x cubed minus x equals 0. If I take common factor to the x, it will be x that multiply 4x squared minus 1 equals 0. And this is 0 if this is 0 or this is 0. Is the first a multiplied by b is 0 if a is 0 or b is 0. So here on this equation, this one, the solution is that x equals 0 or 4x squared minus 1 equals 0. And when 4x squared minus 1 is 0 is when 4x squared equals 1. And when this is happening, when x squared equals 1/4. And when this is happening, when x equals plus minus a square root of 1/4. So, but the square root of 1 is 1. The square root of 4 is 2. So it's when x equals plus minus 1/2. So the possible solution for a slope 0 are the points 0, x equals 0, and y equal, well, if x equals 0, y equals 12. Y equals 12. X equals 0, y equals 12. X equals 1/2, and y, you calculate the y. X equals minus 1/2, and y, you calculate the y. So you have 3 points with a slope horizontal. Okay, and this is the problem. Let's go to the next one. So problem 7 say like this. They give you a function and they ask you to represent the graph of the derivative of the function. So in this case, they give me a rectilinear line. What is this rectilinear line? Well, it may be 3x plus 4. So what is the representation of the derivative? The derivative of 3x plus 4 is 3, is the slope. The slope is 3, so the representation of this graph should be an horizontal line with a slope 3. 3. The slope f prime of x is 3. If they give me this function, that is a constant, what is the representation of the derivative? If a function that is constant, it never changes. If it never changes, the derivative is 0. So the function should be something like this, 0. The height is 0. And what happens if you have a function like this? If you have a function like this, the derivative is negative when x is smaller than 3. Let's say that this is a function with a slope minus 5. And this is a function with a slope plus 5. M, the m is... So what is the representation of the derivative? Well, when x is smaller than 3, should be minus 5. When x is bigger than 3, should be 5. The slope should be plus 5. So the derivative y prime of x or f prime of x is like this for this kind of function. Let's go to the next problem. You invested $1,000 at 8%. Well, and they say if you compound it monthly, if you compoundly per day, what is your final amount after 2 years, after 5 years? So see problem 3, because we have done and it's on the video. I leave you this problem to you because you have done on test 3 and it is supposed that you know how to use the equation correctly. So they will ask you, compound monthly. Compound, what is the final amount of your investment after 2 years? Compound monthly. Maybe compound every year, or maybe compound every day. Compound every day. And see, compound continuously. So it's e to the RT. Is A is the initial amount, A is 0. E to the RT, this is the when you compound continuously. If you have any doubts, please contact me or see the video about compound interest in the playlist. Let's go to the next one. The next one say find the area of the curve that is between x equals 0 and x equals 4. Okay, this is the function f of x. So the function is 3x plus 4. So when x equals 0, this is 4. So the function is something like this. And x equals 3 is here, and x equals 6 is here. On here, there is an area. And it say, find this area. How you will find this area? To find the area, you find the antiderivative of the function. And you evaluate the antiderivative of the function at the endpoints, 6 and 3. What is the antiderivative of 3x? 3x squared divided by 2. What is the antiderivative of 4? 4x. Because 4x, the derivative is 4. So the antiderivative is 4x plus c. So this is the function f of x that is the antiderivative. So to find the area, I find f of 6 minus f of 3. What is f of 6? 3 multiplied by 6 squared divided by 2 plus 4 multiplied by 3 plus c. Plus 4 multiplied by 6 plus c minus f of 3. F of 3 is 3 multiplied by 3 squared divided by 2 plus 4 multiplied by 3 plus c. The c will cancel and this will be a number. And this number should be the same area that you will find if you do the area of the triangle and you add the area of the rectangle. The area of the rectangle is 3, and this point is, when x equals 3, is 9 plus 4. 9 plus 4 is 13. So the area will be 3 by 13 by the area of the square. And the area of the triangle will be, this is 13, and now the total length here is f of 6 by 3 is 18. 18 by plus 4 is 22. 22, so 22 is everything. So this is 13. 13, so 22 minus 13 is 9. So 9 plus 13 is 22. So the area of the triangle, the area of this triangle is the base 3 by the height 9 divided by 2. So the sum of these two numbers, 13 by 3, 13, this is 39, plus 9 by 3 is 27 and a half, 27 and a half. The sum of this number is exactly the same than this minus this. Okay, you can check it. We did it in class and you can check it. Let's go to the next problem. Find the derivative of a function using the limit definition. The limit definition say like this. F prime of x is the limit when h approach to 0 of f of x plus h minus f of x divided by h. What does it mean this? It means you have the function f of x. You take the point x. You take the point x plus h. The point x plus h will have a height. The point x will have a f of x. So you make this rise divided by the rank. The rise is this part. The rise is this part. This is the rise. The rise is f of x plus h, everything minus f of x, where f of x is this height. The rise divided by the rank. The rank is this, or this is h, because from x to x plus h, the distance is h. So when you do the process by a limit, you find the derivative when h approach to 0. So the derivative is a process limit when you do the rise divided by the rank in the limit when h approach to 0. So let's go to do it for this function, y equals square root of x. If y is equal to square root of x, will be the derivative respect to the x of the function square root of x. What will be? It will be the limit when h approach 0. Of what? Of f of x plus h. X plus h. If the function is square root of x, f of x plus h, if the function f of x is a square root of x, f of x plus h will be a square root of x plus h minus f of x. I'm following my definition of the derivative. Minus f of x minus the square root of x divided by h. Now you need to do this limit, but as I have shown you, to do this limit, you multiply by the conjugate of the numerator. Let's go to multiply by the conjugate of the numerator, and we multiply by the conjugate a square root of x plus h minus plus a square root of x divided by the same thing, so we don't alter anything because we are multiplying and dividing by the same. See, numerator and denominator are the same thing. So this is the limit when h approaches to 0 of, if I multiply this by this using the distributive property, will be x plus h plus a square root of x multiplied by a square root of x plus h plus a square root of minus the square root of x multiplied by, I don't put it, minus x divided by a square root of x plus h minus a square root of x plus a square root of x. And now I have 1 divided by h, here this h, here h. And now this is h in the numerator, h in the denominator, a square root of x plus h plus a square root of x. And I have to find this h will cancel with this h, so I have to find the limit when h approaches 0 of 1 divided by a square root of x plus h plus a square root of x. Now this limit is 1 divided. When h approaches to 0, a square root of x plus h approach to a square root of x plus a square root of x. So this is 1 divided by 2 times the square root of x. So doing this limit definition, you can find the derivative of the function. The derivative, if f of x is a square root of x, or x 1/2, f prime of x is 1/2 x raised to the power 1/2 minus 1, which is minus 1/2. So it's the same thing that here. It's the same thing that here, but we don't use a rule. We use the definition. On the exam, you will find a function. F of x equal, let's say, I'm invented a rectilinear line. F of x, 5x plus 7. And you do the derivative. You do f prime of x. Oh, we know what is f prime of x. It's the 5. Is the slope is 5. But the problem is asking you, use the limit definition to calculate the slope. So we do the limit definition, the limit when h approaches to 0 of f of x plus h minus f of x divided by h. Let's go to do it. F of x plus h, if f of x is 5x plus 7, f of x plus h, what do you think that will be? Will be 5. Now instead of putting x, I put x plus h, my plus 7. So it's 5 times x plus h plus 7 minus f of x. But f of x is 5x plus 7 divided by h. And the limit when h approaches to 0 will be the limit when h approaches to 0. Now you do a little bit of calculation. Here is 5x. Here is 5x. Gone. 5h. I see 5h in the numerator. I see that 7 goes down, goes out. The 7 cancel, divided by h. And the limit is h divided by h is 1. The limit is 5. So I have calculated for this function the slope. And the slope is 5, applying the limit definition. Let's go to the last problem, I hope. Now, this problem, that is problem number 4, I think that you should leave it until the end. You can skip this problem now and you can come back later. Why? Because it's a little bit, maybe you are tired of the first 3 problems and maybe you need a relax. So let's go to problem 5, 6, 7, 8, and 10 and you'll go back to this problem. So now I'm going to solve it. And I'm going to give you the whole ideas. The problem say like this: you have an hotel. You are the owner of the hotel. The hotel have 1,000 rooms. So if you can have your hotel full, means that the number of rooms here, is 1,000. And if you can have it fully booked, the hotel, and maybe you can have it fully booked at the price of $120 per room. So it means that you are here at this point. The hotel is full, is 1,000 room, is rented at $120. But now you realize that the marketing advisor is tell you, if you increase the price in $20, so it means that now you are going to charge per every room $140. If you increase the price, you will not have full capacity of the hotel. You will lose 50 rooms that are not being sold, are not being rented. So you will be at this point, 140 and 950. Now, what is better, this point or this point? You may say, okay, I have 1,000 room. If I rent it at $120 per room, I will have 120 by 1,000. I will have my money that I will have will be $120,000. So if I go to this other position, let's say 950. Am I renting $950? But I rent it at 140. Do I have more money or less money? Well, if I do the multiplication, 950 rooms that are rented at 140, the amount will be $1,033. So it's better not to have the room at full capacity. So the question is, where do I stop? But there is another question. To maintain 1,000 room, it costs you $50 per room. Oh, so if you have to spend $50 per room that is in capacity, you will have to invest more money. So the question is, what is the point in this graph that makes you the profit, the biggest profit? So we need to find the profit function, finding the derivative of the profit respect to the Q equal to 0, and we will find the quantity Q, the derivative of the profit respect to the Q equal to 0, and find which Q for what capacity I'm having the biggest profit. So the cost to clean the room is say $60, but maybe I change it here. The cost, I put it 50. So let's go to put here $50 per room, 50. Okay, every room cost to clean and to maintain $50. To change the sheet, to clean, to whatever. So how you do this problem? The first thing that we are going to do is to find this rectilinear line, this one. Now I know the slope of this rectilinear line. The slope is the rise divided by the run. The rise is 20 and the run is 50. So the slope is 20 divided by 50, but it's a negative slope, so it's minus 20 divided by 50. And minus 20 divided by 50 is minus 2/5. The second thing that I'm going to do is to find the curve, the P of Q, to find who is P of Q. What is the price as a function of the occupation, of the quantity of the Q that is being occupied. So the rectilinear line is P equal P0 plus M multiplied by Q minus Q0. So if I choose this point, that is the point 1120, this is the point P0, comma Q0 is the point, the point is Q0, the X first, the Y later. Q0 is 1000, and the P0 is 120. So, if I insert this data into the equation of the rectilinear line, I will have P equal P0, 120, P0, minus M, 2/5, minus 2/5, multiplied by Q, minus Q0. Q0 is the point Q0 is 1000, Q minus 1000. So if I work a little bit with this equation, I will have that P of Q will be minus 2/5 of Q plus 520. This will be 2000 divided by 5. 2000 divided by 5 is 400. So it will be positive 400 plus 120, it will be 520. So the cost to maintain an occupation of Q units is $50 per unit. So the cost will be 50 multiplied by the number of rooms that are occupied. More rooms occupied, more cost. And the profit is the revenue minus the cost. So the profit is the revenue minus the cost. So in this problem, what we do is we create the function profit, the profit as a function of Q, or the amount of rooms that are occupied. So the profit P as a function of Q is the revenue. The revenue is the money that goes to your pocket. And the money that goes to your pocket, I said at the beginning, it depends where you are. Here, you will have $120,000 because you have 1,000 rooms that are fully booked, multiplied by $120 per rooms, so you will have $120,000. But here you will have 136,000. But listen, you have money to spend to occupy the room. Let's go to see what is the best point for having the biggest profit. So we construct the function P of Q, and this is the function P of Q, the revenue, Q by P, Q multiplied by P, minus the cost. The cost, the total cost is $50 per room. So it's 50 multiplied by Q is the total cost. So, but we know who is P of Q. P of Q is minus 255 multiplied by Q plus 550 minus 50Q. So at the end, we can work with the profits as a function of the quantity Q, and it will be minus 2/5 Q squared plus minus 50Q plus 520Q. This will be 470Q. So this is my equation for the profit. How do I find a maximum? The derivative of P respect to the Q equals 0. If I make the derivative of Q by of P respect to the Q, I will have minus 4/5 by Q. The derivative of 470Q is 470 equals 0. So from here, I can solve for Q, and the Q is 587.5. Of course that you don't have 587.5 rooms, but let's say that it's possible to rent half of the room, this half room. So if you have this, if you are at this position, you are at the biggest amount of money in profit. Okay, so this is the price that you have to, this is the amount of rooms that you have to rent. At what price? Well, P of Q is minus 2/5, Q plus 520. P of Q is here. P of Q, we found it at the beginning. P of Q is here. So if Q is 587.5, I think that if you multiply, you find the price P at which you are rented each room. So the price P will be 285. So what happened now? That the profit, the maximum profit occur when you have your hotel with 588 rooms, we can say. 588 rooms occupied at the price $285 per room. And what it means, what amount of money will you get as a profit? The amount of money that you will get as a profit would be Q by P, 587.5 by P, by 285, minus 50 by Q, minus the cost. The revenue, Q by P, minus the cost, 50Q. So if you make the numbers, you will find that here you have as a profit 138,112. It means that this is the best possible situation for you to have at the biggest profit, to have only 587 rooms occupied, not all, but having them occupied at $285 per room. If you do the calculation for when you are fully occupied, if you are fully occupied with 1,000 rooms, so the profit when is 1,000 rooms is P by Q. Is 1,000 multiplied by $120 per room. So you will in money that is coming to your pockets will be 120,000. But you are spending money to maintain the rooms. You are spending $50 per 1,000. So you will have 120,000 minus the cost to maintain the 1,000 room occupied. The total profit will be only 70,000. So the best position is this one when Q is 587 for this problem. For the problem on the exam, you have to figure out how to do it. Q is 587 and P is $200, $285. So, as I said, if you don't catch this problem now, leave it until the end. The last problem is this one that is a little bit more difficult, and I hope this will help you a lot. As I said at the beginning, if you work this problem by yourself, you do a video to yourself, not to me, to practice this problem, I can assure you, you will do very, very well on the final test. But you need to play with these ideas. You need to figure out how to do the problem in a different situation. How it will be a different situation? Well, different situation will be for this problem that you don't have an hotel with 1,000 rooms. Maybe you have an hotel with 500 rooms. Well, big change. Maybe the price per room is not 120, maybe it's 110. Wow, big change. And maybe the cost to maintain is not $50 per room. Maybe it's $20 per room. So you need to figure out how to do the problem correctly. I'm sure that you can do it. I'm sure that if you practice the whole weekend with all this video, you will do very, very well. I wish you all the best. It was a pleasure to be your professor during this term. Anything you need, I'm here to help you. If you need to make a Zoom meeting with me, just send me a message on Canvas and I will connect. Whatever you need, I'm here. Good luck.